Okay, let's talk a little bit about the difference between accuracy and precision. So, accuracy is really pretty simple, and we can do that with just starting with a single measurement. So, let's imagine for a second that I throw a dart at a dartboard and I hit it here. I was aiming for this bullseye, but I hit it right here, right? The accuracy is how close I'm able to get to that. And the only thing that's kind of confusing about this is we really usually talk about it in the reverse of that. We talk about an error. We talk about this distance from where I was shooting at and where the measurement is, okay? And when the error is small, the accuracy is high, okay? So when I get real close, my accuracy is high and my error is smaller because this distance is shorter. Okay. Now typically, so that's a, two-dimensional sort of thing that you can visualize, but often we're just talking about a single measurement. And in the single measurement model, it's really more like we're looking at a number line. Okay. So here is the number that I should have gotten. I'm calling this a little X star here. And then say I make a measurement and I get right here, x1. Yeah. So in this case, I have an error that is just this distance right here. And the distance between 2 points on a number line is going to be given by the absolute value. So the positive, so if this is negative, we're going to make it positive. If it's positive, we're going to keep it positive, of the difference between the two. So the X star minus the X1. And in some books and in some cases, they even allow for this to not even be the absolute value, to actually have negative error. But most of the time you're going to see that they just want you to always have a positive value there. So that difference is going to be this distance, and that's going to be my error. Now, the next thing that you're going to see that they do is they want to define something called the percent error. And the reason they're doing that is because this doesn't really have any scale now, right? So I could have an error of 67, right? And that could be really, really high, right? Like if I was shooting for 2 and I got an error of 67, well, I'm way out of the ballpark, right? But then like if I was shooting for like 70 million and I got an error of 67, well, I'm pretty close. I mean, there's a different sense of scale depending on where we are on the number line. And to correct for that and give you some sense of that, they do something they call the percent error, where I take this error, this distance right here, and I divide that by the actual value that I should have gotten, my X star. And then I multiply that by 100%. So it's basically like saying, what is this distance as a percentage of this number? And we're going to see that in the labs, these are going to come up. They're going to ask us to make some measurements and to calculate error and percent error. Now, this did require that I know what this value is, right? That I know what the actual value is, which almost never happens. So typically what you're going to see, you're either going to be given a known value that has some sort of providence, somebody smarter than you figured it out, or sometimes you're going to replace this with just the average of a bunch of different measurements. And both of those cases can be valid given what the circumstance is. Now, precision comes in when we start to have many different measurements. So if I threw a bunch of darts up here and they just land wherever on the old dartboard, okay, this is not very precise. Even if I get a value that's really close to where I was aiming for, it's still not precise, okay? It's a different thing than accuracy. However, if I threw some darts at a dartboard and they all grouped together, even being far away from where I wanted to go, but they're all together with each other, this is precise. So precision is a measure of, if I make a whole bunch of different measurements, how closely together are those going to get grouped? Now, our mathematical descriptor for precision is going to be the standard deviation, and it has a pretty, it's often abbreviated with this Greek sigma. It's got a pretty gross looking equation that goes along with it. But I don't want you guys to be scared of this guy. We're going to talk about this in some other videos and work on it there. But it does also bring in the idea of the average of these different measurements. And the average is something that we can handle pretty easily. The average is just going to be the sum of all of our different measurements. So the first measurement I took, the second one, the third one, divided by n, which is the number of the measurements. So if I took 3, n would be 3. If I took 4, n would be 4. Okay. And that's what this plus and then these 3 ellipse dots here means, is that I could add up many, many different measurements. It could just keep going on and on. I'm not really specifying how many I did.